Good morning, everybody, and welcome to a very special edition of MetalCon Live, Decoding the Language of Metal Construction with Bob Zabzik and Todd Miller, two fantastic individuals. One is from Isaiah Industries and the other from the MCA. Today's presentation is being done in partnership with the Future Leaders, an MCA and MetalCon joint program. The Future Leaders program is dedicated to bringing top-notch education and networking opportunities to all future leaders of the metal construction industry. To find out more about upcoming Future Leader happenings, please feel free to reach out to Zanat Ali from the Metal Construction Association or me. I'm Kaylin with MetalCon. We are both happy to share any and all information with you about upcoming events and any additional information you may request regarding the Future Leaders program. Stay tuned. We do have some more information and some additional webinars coming later on this spring. Speaking of upcoming events, we also have another webinar coming up on April 5th. Make sure you mark your calendars. This one will be Heidi Ellsworth of Metal Coffee Shop and John Kenny of Cottony Consulting, and they'll be presenting Planning the Future of Your Business in a Digital Age. And I'm so excited to announce this, everybody. On April 3rd, less than 2 weeks away from today, registration for MetalCon is opening. So in the meantime, between now and then, our housing is also open. So make sure that you go ahead and check out our website and make sure that you get right in line for those housing opportunities, as well as the registration as soon as it opens, again on April 3rd. We are also excited to announce we have an exciting mix of new and returning experiences happening. We've got lots of new experiences. We have new and returning exhibitors, plus, as you all know, tons of education coming to the show floor as well. Finally, if you run into any technical issues, please message MetalCon Live in the chat box and I'll be the one to help you out. For any other questions or comments or concerns that you have about anything going on in the presentation, you can shoot those to myself or to any of the panelists in the chat box or in the Q&A. Both can be found at the bottom of your screen. I'm sure you're all tired of hearing me talk by now, so I'm going to leave it to Bob and to Todd. Bob and Todd, take it away.
Thank you, Kaylin. Appreciate everybody joining us this morning, afternoon, I guess, for a lot of people, myself included, actually, by a couple of minutes. And we are presenting a presentation today called Decoding the Language of Metal Construction. As Kaylin mentioned, I'm Bob Zabzik. I am the Technical Director for the Metal Construction Association. And joined with me today is Todd Miller of Isaiah Industries. Todd, hello. How are you today?
I'm doing well, Bob, and looking forward to this.
Fantastic. I am too. I have been very blessed to know Todd. He and I have got a lot of things in common. You know, it's interesting too that let me just tell you why we're choosing this subject and why we brought this up. So as Kaylin mentioned, we have a Future Leaders program that we're presenting throughout the year this year and into the future at MCA. And the impetus of this very presentation stems from those future leadership sessions, in particular questions from some of the attendees, quite frankly. When you say, you know, LTTR, Bob, what do you mean? And so we sat down and kind of went through some information with a couple of other members, Todd and myself also, and just came up with this presentation, which will kind of hopefully shed a lot of light on some of these really esoteric terms, what they mean, and how you when we use them. And we do this, I know when I'm doing MCA meetings, I'm talking really fast and acronyms are my best friend. So I do that just out of the interest of time. So we're going to cover acronyms as well as terminology. But I will warn you, Todd, go ahead and advance the slide. This is kind of a dry subject and there are some dad jokes ahead, just to keep things interesting. So we'll move right along into it. Todd, if you would, kick us off.
Sounds good. Well, I'm going to start out by sharing a real quick, short, kind of sad story. So I've got a good friend. He had kind of fallen on some hard times in life and really wasn't doing well. So he actually went to an exorcist. The exorcist did his thing. He was actually doing pretty well for a while, but then he forgot to pay the exorcist. So he got repossessed. Anyway, okay, we had to start with something. Anyway, you're absolutely right, Bob. There are so many terms and so many acronyms in our industry, and we could probably do this for several hours.
Right.
But we're going to hit some high points today, and we will welcome folks if they have questions to go ahead and enter those, and we'll address those either as we go or at the end. So let's kind of start off by looking at just a general roof. And so we're going to look at some of the terms on a roof, and some of these terms, even though we're talking about in terms of their use in metal roofing, a lot of them also apply to metal wall panels as well, or at least very, very similar terms. So as we go around the roof, we can start with some basic technology or roofing terminology. And so here you see some of the basic parts of a roof being pointed out. Some of them on top of the roof, such as the hip, of course, your rake trim, your eave trim, your ridge trim. But then you also have areas underneath that, the soffit, which would be underneath, and the overhangs. Also your open gables, which are going to have some overhangs to them, and soffits as well. We got something pointed out there that's called a cornice, and I hear those called about 10,000 different things, and wraparounds and Victorian this and that. So there's all kinds of terms used to some of those decorative type areas that might be on a roof. But then, of course, in the field panel, at least in the metal industry, we either have some sort of a metal vertical panel or a metal shingle panel that would be used in the field areas of the roof. So looking a little bit further at the roof, on a hip and valley roof, of course, we're pointing out here where the hips and valleys and ridges are. One of the things I wanted to point out too is that sometimes I'll have folks ask me, they'll look at a roof in a northern climate, or they'll see a photo and they'll ask, what are those little pointy things at the bottom of the roof that are sticking up? Well, those are snow guards, and there also can be snow rails and different ways of doing that. But basically, those are all systems of snow management. One of the things, of course, that metal roofs are fairly well known for is shedding snow loads. And a lot of times what happens is you get a snow load on the roof and the sun comes out, you get a little bit of radiant heat stirred up from the sun, passes through the snow load that's sitting on the roof, hits the metal, warms up the metal as it starts to reflect back out, and all of a sudden the snow load releases and tends to slide all at once. A little bit like some of us up north may have seen happen when our engine heats up the hood on our car, and all of a sudden that snow lets loose. But well, that's only if you're bad like me and you drive around with tons of snow on your car, which isn't the smartest idea. But anyway, so we use these snow guards, and they typically will be staggered over areas of the perimeter of the roof that you want to protect, and you're going to want to protect doorways to keep from blocking them. You may also want to protect delicate shrubbery or statuary or things like that that may be in firing range of that snow sliding off the roof as well. So that's what snow guards are. So let's dig a little bit deeper here. And we're going to look at the different types of metal roof panels. Now, again, some of these very similar terms would apply to wall panels as well. So we're going to start by talking about snap lock standing seam. These are panels that are typically from 12 to 18 inches wide, and then they got a raised rib or raised seam, a standing seam in between the panels. When they're installed, the female lock on one side of the panel snaps over the male lock of the adjoining panel, and the panels may be secured either with hidden clips that attach to that male lock and then are fastened to the roof deck, or some of the versions of snap lock standing seams have a hidden fastening flange as well, which would be a flange with slotted holes that screws would go through. We oftentimes call those nail hems, but we don't really use nails through them. We would be using screws. Typical minimum pitch for a snap lock standing seam is going to be 212. But then we got mechanical seam standing seam, very similar to the snap lock, except the panels are put on the roof, and rather than be snapped together, you run some sort of either a seaming machine, or the old school guys do it with tongs, but you actually mechanically fold that interlock into a watertight seam. One of the benefits of that type of seam is it can be watertight down to very low pitch, even as low as 1/4 and 12. There again, these panels tend to vary a little bit in width, probably on the wider end, typically, maybe more in the 16 to 20 inch range for that type of panel. But once again, all the fasteners are going to be concealed. A mechanical seam, standing seam, is going to have a clip fasteners rather than that fastening flange that I spoke of earlier with the snap lock variant. So then we also have modular panels available in the metal roof industry, and these are actually press formed panels. Got a lot of different producers, and they all have different designs, and they got different dimensions. A real common sort of dimension would be something maybe in the 12-inch by 48-inch range. So 12 inches top to bottom, 48 side to side. And then the panels either interlock or overlap on their sides. You've got some panels that interlock on all sides. You got some that overlap on all sides, and you got some that overlap on 2 sides and interlock on the other 2 sides. So a lot of variants out there. There again, usually with the modular panels, they have hidden fasteners, not always, but usually. And a lot of times these panels are press formed to look like more traditional roofing materials. So they've been stamped to look like slate or wood shakes or shingles, or even barrel tile for that matter. And then finally, another type of metal roof panel, and I don't have these in any particular order here, but another type of metal roof panel is what we call exposed fastener panels, or through fasten panels. So these are basically sheets of corrugated metal, various profiles. You got R panel, PBR panel, 5E crimp, other ag panel, other profiles as well. But they're basically secured to the roof with screws that are driven right through the panels. Those screws then have a rubber grommet or washer on them to keep the water from infiltrating around the screw hole. And so those are the 4 basic types of metal roof panels. And again, you got similar variants available on the wall side as well. Little bit more larger terms looking at on these types of panels is structural versus architectural panels, and you'll hear those terms thrown around on occasion. So structural panels are panels that do not require solid decking underneath of them, so they can literally span over the trusses and the other structural members of the building. So they can free span over those structural members. They don't have to have solid decking underneath of them. Architectural panels, which are also sometimes called non-structural panels, architectural panels, on the other hand, do require some sort of solid decking underneath of them. So just for clarification here, most of the modular panels being made are architectural panels, meaning that they do require solid decking. So solid decking, of course, can typically be wood, such as CDX plywood or OSB, or it also can be a metal deck as well. Another option we run into on older structures sometimes is the roof deck is dimensional lumber, but it's what I call closely fitted. The gaps in between the boards, maybe 1/4 inch or so, but there are no significant gaps between the boards. And then you've got battens. So battens would be used more in that structural application I spoke of earlier. So battens can either be wood or they might be metal. Certainly on metal construction buildings, they would be metal. Those battens are typically running horizontally, and then you would have the vertical seam roof panels installed spanning on top of them vertically up the roof, but the battens are running horizontal. Now, another variant to that sometimes is to actually cross batten, where you would run vertical battens and then horizontal battens. And the purpose of that is to give you some nice air chambers up the roof for ventilation up the roof beneath the metal panels. So when you put those vertical battens down first, creates these nice vertically oriented air cavities so you can bring fresh air in at the bottom, exhaust it out at the top, and get some good ventilation. So ventilation, as I mentioned here, can be done in that case above the deck, which we call above sheathing ventilation, or ASV, or ventilation can also be more typical what we see, which would be ventilation in the actual attic space beneath the roof deck. So let's keep on going here. A few other terms, valleys on a roof. The valley is the intersection of two roof planes. We saw that on that L-shaped building drawing, roof drawing we looked at earlier. Valleys, of course, can be a common area for roof leaks to occur. So typically on a metal roof, they're going to line that valley with some sort of matching metal that matches the rest of the roof. And then you've also got a couple of variants of valleys, open valleys and closed valleys. Open valleys typically will have a valley pan put down and then a cleat on both sides of the center of the valley. And the panels come into that cleat and they actually lock over it. We call this open because everything's out in the open. Nothing is concealed. On the other hand, a closed valley is more sort of a, if you can imagine, two J channels back to back in the valley that the panels are received into, or something like that. So closed valleys, create a little bit of closure there to help protect against weather. But the problem is closed valleys can also be prone to clogging with debris on the roof, because as you can imagine, everything that ends up on a roof, if there's a valley, it's going to end up in that valley at some time, just because gravity is going to carry it there. And so if you've got a valley system that has closed channels, those such as J channel type areas, those areas might collect that debris, which could be tree leaves or pine needles or ice or snow for that matter as well. And then finally, we also have Death Valley. Oh, wait, that's a really hot, dry place in Central California. That has nothing to do with roofing, although we do have dead valleys.
That's right.
And dead valleys are eave to eave situations, which can be nasty critters to work with. But there again, typically you're going to line a dead valley with metal to match the rest of the roof. Ideally, you'd probably put some sort of a saddle or cricket in the middle of that dead valley to help kind of push the water one way or the other, or perhaps both ways. And there's our Death Valley sign. So let's look at some other terms. Flashing. Flashings really are kind of generic terms that are used to refer to the pieces of metal that would be used to keep water from going into a joint. So let's say, for example, you've got a roof that abuts against a wall, or it runs into a chimney, or it runs into a skylight. Those are areas where you're going to flash. One of the interesting things about metal roofing, a lot of times when you look at traditional shingle roofs, you'll see flashing on walls, and it's what we call step flashing. So it's these small 8x8 pieces of flashing that are stepped down that protrusion, whatever it is. Typically in metal roofing, we actually use lineal pieces. So those would be flashed with a continuous lineal piece rather than those small step flashings. Drip edge is going to be at the bottom edge of the roof, and that's basically to, as the water exits the roof, to direct that water someplace, hopefully away from the building. If there are gutters on the roof or some other kind of rain control, water control, the drip edge is going to direct that water into the gutters. Cleats, we're going to look at a picture of those here in a second, but cleats are basically a method of being able to put trims on a roof and not have any exposed fasteners. So we'll look at that in just a second. Finally, I want to talk about underlayment. Underlayment typically would be used on a roof that's being installed over solid decking. And the underlayment is going to be a water resistant or waterproof barrier that is installed directly over the deck. Goes underneath the roofing materials. It provides an added layer of protection in the event of severe weather. But sometimes metal roof installs take a little bit of time. So you want to make sure that roof's protected by a good underlayment. during the process of installing the metal panels as well. And a lot of the trend in metal roofing in recent years has been toward what we call synthetic or polymer-based underlayments. These are still mechanically fastened, so you nail through them, typically using plastic cap or roofing nails. But they are not the old asphaltic felt underlayments, so they ain't your grandfather's underlayment, I guess you'd say. But then we also often, as required by code, you'll use ice and water shield around the perimeter of the roof, maybe up the valleys, maybe even up the gables. One of the very important things with ice and water shield beneath metal roofs is to use a smooth surface or a rubberized surface ice and water shield, not a granulated or sanded surface underlayment or ice and water shield. The problem with the granulated and sanded surfaces is, as the metal panels sit there and expand and contract with some thermal movement against that abrasive surface, it's going to scratch the backside of the metal roof, which could cause problems down the road. So again, you want to make sure that your underlayments always have a smooth surface for them. Oh, another reason for that too is you want to make sure that your metal panels don't end up sticking to the underlayment, because then again, with expansion and contraction, it's going to stick to the underlayment and tear it or cause problems, cause it to bunch up. So here's that cleat deal I was talking about. Nice drawing here Bob made with a eave detail where they've got a cleat. So you see that lower piece there that the screw goes through where it's being driven into the fascia, that is the cleat. And so then the drip edge is snapping over the cleat on the bottom edge. The drip edge is going to be screwed into the roof deck in a concealed area. But what this does is it allows you to have a nice drip edge there that has absolutely no exposed fasteners. On the other hand, that drip edge is held firmly in place, which helps a great deal with it. Wind uplift to make sure that the drip edge doesn't blow up on you and cause problems of wind infiltration as well. So with that said, Bob, I'm turning it over to you.
Hey, thank you, Todd. If you just back up one slide, I did want to point out one thing.
Please.
Cleats are important, as Todd said, not just to conceal fasteners, but they also provide a means to address linear expansion and contraction without creating that binding situation at the fastener. So I wanted to mention that. I also wanted to mention, and this is my fault, I'll own it and fix that, but I've got arrows swapped. So the cleat is actually pointing to the cleated edge trim, and the second leader of the cleat edge trim is actually pointed to the cleat. So I'll fix that little hiccup in the slides here. Yeah, so that's one thing I want to point out. So thank you for that. And yeah, I was going to get into kind of the underlining materials and talk a little bit about paints and finishes. This stuff has been, it's old terminology in this industry. We used it forever, but it's funny that as we've gone along, some of these definitions may not be exactly what you think. And that's really Gauge is a good example of this. I've very carefully worded this definition. A numeric identifier for steel less than 3/16 of an inch thick, and that's actually called out in a couple of different standards. So 3/16, you actually use the thickness as expressed in fractional inches, but if it's below 3/16 inch thick, you use this gauge identifier. A smaller gauge number means a thicker steel, and I got just some examples on the next slide. And also a gauge represents the uncoated or represents the thickness of the uncoated steel. So the metallic and paint coatings add to this. Now, what is not called out here is that there is actually not a consensus-based written standard that says 26 gauge is equal to X millimeters or fractional mils, mill inches or fractional inches. That does not exist. And a big reason why, although 26 gauge from different manufacturers, those decimal thicknesses are very, very close, generally speaking, from the different manufacturers, but they won't match exactly. And really the reason why is when this terminology was evolving, there were really two main steel manufacturers in the United States, US Steel and Bethlehem. And they were kind of the 700-pound gorillas. What they'd established was gauge. There was no need for a consensus. The two of them agreed on it, then that was the consensus. And of course, now that it's a little different. We have a lot more steel suppliers, different rolling technologies, tolerances have increases. And so what it means is 26 gauge from different manufacturers won't always match. And a lot of people are surprised to hear that. So we did write a metal properties white paper on the MCA website, and we can send that link out to you. You can probably find it yourself by simply searching, that talks about that. And that's actually where this table that I'm going to show you in a second, where it originated. But coil, well, that seems pretty obvious what a coil is, right? There's some interesting tweaks to this too. A length of gauge steel wound into coil form. The width varies, but coils are usually, 48 to 60 inches wide. Larger coils, they can be slit down to smaller coils to manufacture different types of products from there. But we're talking about the base coils. Usually an interior diameter 16, 20 inches, an outer diameter 48 to 72. If you do the math on that, we're talking about materials that are 0.025, 0.03 inches thick. That's a whole lot of material. They can be thousands of feet long rolled up. And then there's flat stock. Also sounds obvious. Maybe it's some interesting things there you aren't aware. Most flat metal panels come from flat stock, but flat stock comes from coil. And when you wind coil, those dimensions that you see up there in the interior diameter, outer diameter are carefully chosen on the basis of the thickness of material, so that the interior winds of that coil don't actually reach the elastic limit, and there shouldn't be any memory. In other words, the coil trying to take back its round form. But of course, if it sits in a banded coil position long enough, it will have some memory to it. So you actually have to decoil or flatten material for flat stock. We do that in an inline process in this industry quite often. But that's really the difference between gauge, or what these three interrelate really: gauge material, coil, and flat stock, because we'll ship flat stock to make special pieces in the field. Or we will make unique boxes, trim boxes, cornices, like we saw earlier, out of those materials instead of from coil. Coil generally is used to produce panels or some type of blank for other piece of material that's being made from it. So it's some of that terminology does cross over. So that's why I wanted to bring that out. So next slide. So here's an example of what these material thicknesses by gauge look like. This is not, again, consensus-based standard. This is just, if you run through the ASTM calculations, this and consider the thicknesses of the various coil coatings, this is what you're going to see. The base material thicknesses are generally speaking the same, and that's what the dark numbers are. But then when I add the different coatings and materials to them, I get different thicknesses on the basis of what that coating is. And so this just shows you how that varies versus the most common gauges that we see in this industry, which are 22 gauge, 24, 26, and 29. So again, decimal inches here. You could convert those to millimeters if you want. And those coils, perfect timing, Todd, those coils are generally speaking either bare, galvanized, or galvalume, or they're painted, which leads us to our next term, Kynar. So a little multiple choice for you. Is Kynar on Star Trek a cross between a Klingon and a Vulcan? Is it a paint system typically used on top of galvalume or galvanized steel or aluminum? Widely recognized as a high quality finish, usually carrying a chalk and fade warranty. Or see, a small island in the southern Indian Ocean. If you can't get this one, I can't help you. The answer here is obviously B. But just for grins, I wanted to put out there, because I did kind of, when I see the word Kynar, that's what two things that popped in my mind: a Klingon and a Vulcan. It kind of fits together. So there you go. God loves Spock. He's one of my favorite characters on any television show or movie ever. All right, next slide, please. So I've talked a lot about galvanizing, well, some about galvanizing and galvalume a little bit. So let's just talk a little bit about metals in general. We all probably have heard the term similar or dissimilar metals. I haven't put those in the slide here because you probably, hopefully you remember from high school chemistry what those are, but really what it comes down to are dissimilar metals, or metals which, when put together in the presence of an electrolyte, which is a liquid media able to transmit electrons, generate some type of corrosion. And similar metals when I put them together into electrolyte, there might be some corrosion, but the two metals don't assist each other in their respective corrosive processes, right? And that's really one of the key things that we're accomplishing with galvanizing. So is typical, as like I said, a process where metals, typically steel and iron, are coated with a layer of zinc to reduce or eliminate the potential for rust. Maybe most people know this or remember it, but in case you don't, that zinc is a sacrificial coating, which means that the zinc corrodes instead of the iron. And this is what makes it very widely used for exterior applications. And so one of that is obviously sheet metal is used for panels and roofs. Now, we generally don't use bare galvanized in most commercial products. Ag products, we do use a lot of bare galvanized. There are actually times, certain corrosive environments where bare galvanizing actually works better. But those are pretty unique and rare. And generally speaking, when we have galvanized, plain zinc galvanized material, we're coating it, again, would be a Kynar or some other type of paint system. And then Galvalume is actually a special coating that was developed by Bethlehem Steel. I want to say in the 70s, please don't quote me on that. But protective coating made from 50 or 50% aluminum, with the balance being mostly zinc, like probably 94, 5, 6% of that balance being zinc. There's a little bit of silicon there. And it's best used in prefabricated metal wall panels and standing seam roofs. Performs well in harsh weather conditions, but should not be used in or around concrete and mortar. That's a very important aspect, because zinc, while it is sacrificial with metal, it even loves, it would prefer to sacrifice itself with calcium more than steel. So what happens is when you use Galvalume and together, or seems true with galvanized material too, that calcium will actually accelerate that process. Now, you probably say, well, brick ties are galvanized, right? Well, they're hot dip galvanized with a very thick coating, and that coating is sufficient to live long enough, if you will. It's not a highly corrosive environment. It's just two more dissimilar metals, just to put a weird term to it. But so that is actually okay, because I have designed that piece to have sufficient sacrificial coating. Now, what the aluminum does, yes, so there is some aluminum replacing zinc, but what really cool things about aluminum is that when aluminum oxidizes, it gets very hard. If you've ever seen metal sandpaper that's designed to sand metals down, they're generally aluminum oxides. They're very, very hard, durable materials. So if you remember, we're taking, like we talked about earlier, we're taking flat stock, or coils rather, turning them into flat stock, but then we're roll forming these materials or press breaking them. So, and we'll even do that after it's painted, right? So we have to preserve the durability of that coating, both in the paint and in the metallic coating. So the paints are designed to be plastic and they're organic base, like most paints. They're baked on finishes, but they can take that curvature. But the Galvalume is really, really good for the metallic coating at taking that curvature and providing that durability. And so that's why we've really kind of, even in painted conditions, we'll tend to migrate towards Galvalume materials. Not that painted galvanized is bad, it's still used all the time, performs very well. But you will see quite a bit of painted Galvalume as well. And I get asked every once in a while, which one's better? And I think our general recommendation in industry, very, very general, would say that Galvalume is usually preferred, but there are times when galvanizing is the right answer, and painted galvanized actually works better. So I would encourage you to talk to your manufacturers when those kind of decisions come around. So that's the process of galvanizing and how dissimilar metals work. There's a very interesting story here. I'm going to get off a little bit off topic, but I think you'll find this interesting. And as far as I can tell, it's true. I've done a lot of research. I think this is commonly accepted. This gentleman, his name is Luigi Galvani, excuse me. He was an Italian chemist in the late 18th century, about 1780. And you know how, Todd, in these days, if we got a sick loved one, what do we do for them?
Chicken noodle soup.
We make them chicken soup, right? Well, I guess if you're a chemist in Italy in 1780, you don't make chicken soup, you make frog soup. I've had turtle soup. I've never had frog soup. And honestly, I'm not going to rush out and try it. But supposedly it has great healing powers, or at least was thought to at the time. So being the doting husband that he was, Mr. Galvani runs out and then grabs some live frogs from a local market, brings them to his house and harvests the legs off the frogs. He skins them and puts a little salt on them, probably not to season them, but to dehydrate them. And then he hangs them up, and this is where this is pertinent. It hangs them up on a copper wire against his window. That window was an open window apparently, but it had iron bars on it. Well, copper and iron are dissimilar metals. And of course, there's salt and moisture on the frog skins or on the frog legs, and so we have an electrolyte. So lo and behold, the wind starts to blow, and the frog legs touch the iron. They're already in conduction with the copper wire, and they begin to twitch. And of course, we know now that the electrical impulses were the frogs had recently enough alive that their nerve cells still worked, and those electrical pulses were exciting the motor nerves and causing the frog legs to twitch. And this is where the story gets kind of sad, because Mr. Galvani might have been a good chemist. Apparently, he didn't understand biology very well, and he didn't understand that nervous signals, motor nerves respond to electric signals. And he drew the very unfortunate conclusion that the energy was being generated by the frogs, and he had just discovered a very sustainable source of energy. And he had the gall to predict that one day we would all live in a world powered by frog legs. And we all know that's not true, but that is how galvanizing was discovered. And it's a really good example of why dissimilar metals, just putting them together. You don't want to do that as a matter of practice, obviously, but just putting them together generally isn't going to give you the worst case. The worst case is introducing an electrolyte or even just moisture, because moisture can temporarily hold electrons as well. And in particular, that's what accelerates rust or what we call red rust with iron. And so the whole idea here, though, is that the zinc oxidizes in preference to the steel, and those electrons actually never get freed from the matrix, and it prevents further rusting. So there you go. There's some useless information you can pass on to your kids at dinner time. And go try frog soup. Who knows? So with that, Todd, I'll turn you over to cover some manufacturing terms, and then, as I understand, we are at about 20 minutes to go. So I think we're doing all right in time. When you're done, Todd will kick this back over to me, and I'll get into some of the more common acronyms that we run into, and that should bring us on home. So please take over, Todd.
Thanks, Bob. I don't know if I have to live in a world that's powered by frogs. I think maybe I'll live without power. I'm not sure. I did realize, though, I missed my perfect opportunity when you asked, what do you do when a loved one is sick? I really should have said I check and make sure their insurance is paid up.
Yeah, bingo.
Completely missed that one. Okay, let's look at some other. Oh, we got another multiple choice here. So, what is a reverse bend? Could it be A, when talking about a machine that offers reverse bends? It refers to a large machine such as Sedan's Forma Z that has a panel leg bending up and another leg that can bend down as well. So got some double folding action going on there. Or could it be a part that is formed by making one bend and then having another bend in the opposite direction from the first, such as a Z formation? Or could it be a road that turns suddenly more than 170 degrees? Well, the correct answer actually is D. So it could be both A and B as a reverse bend. So it's a particular type of machine, but it also refers to a particular product profile or trim profile as well. So let's look at blanking, another multiple choice here. What is blanking? Is it A, when you're talking and forget what you're about to say mid-sentence, which I tend to do, or forget where I'm going as I'm walking from one room to the other, or why I'm going there? Or is blanking, it'll pull it up here, a metal fabricating process during which a metal workpiece is removed from the primary metal strip The material that is removed then becomes the new workpiece or a blank. So in essence, it's cutting larger flat stock or coil into smaller blanks that can then be used to fabricate various profiles or various trims. And so, of course, the correct answer there is B. So let's look at methods of metal forming. Want to look at three primary types of ways in which metal is formed. One is roll forming. So if you think of that guy that brings a seamless gutter machine to your house and it just rolls gutter out of a flat or out of a continuous coil of metal, that's what roll forming is. Roll forming creates consistent long parts of whatever length you want. Oftentimes the machines are programmable. So of course, roll forming would be the method used for standing seam panels as well as some trims. Big thing on roll forming though is everything is lineal. It's, it's one direction. It's one straight consistent part. Then you also have another method of forming metal, which consists of press brakes, folders, or hand brakes. And these are used to create specific length trims by putting a blank into it and then bending it as you need it to be. Compared to roll forming, a press brake or a folder can be programmed, or a hand brake can be manually operated to create pitch specific parts or even tapered parts. So you think about a roll former, everything is just one dimension, continuous long parts. The variety we get with a press brake or forming parts this way is the ability to do more customized parts that may be specific to the pitch of the roof. And again, maybe tapered parts. So you may have valley pans that are tapered so that one can nest into the other when you're lapping valley pans up the length of a valley. And then the last method of metal forming that's common in our industry is stamping. And these are large, high tonnage stamping presses that are used for producing various modular panels, as we call them. And modular panels are the various metal shingles, slates, tiles that we talked about earlier. There are tooling put inside the press brakes that create those parts. The tooling may be transfer tooling, where the parts have to be mechanically moved from one die, as we call it, to the next between hits. Or tooling can also be progressive, where the part actually stays connected as it goes through the various stations of the die until the final finished product gets cut off at the very end and thrown out of the machine at some ridiculously high rate of speed. No, well, it does happen sometimes. So you got a catcher on the end to catch those parts. Some other terms in terms of metal construction, riveting. Here we've got another multiple choice. Riveting can be A, placing a short metal pin or bolt for holding together two plates of metal, the headless end being beaten out or pressed down once it's in place. Or is riveting B, when you're very interesting and fun to talk to, like Bob? It could
Thank you
be
for
that
lying.
as well. I will say that it could be A or B in this case, but I guess as it pertains to metal and construction, it's probably A. So now we're going to turn over to alphabet soup and send it back to Bob to have acronym time.
Thank you. Yeah, so I'm gonna tell you, those folks who did that riveting in those scenarios, I think we've all seen pictures of Empire State Building being erected, other tall steel buildings in the early 30s. Those people were seriously hard workers and took a lot of dangerous chances in their jobs, and pretty amazing really to watch if you get a chance to see some of those few films that were made of that process. So yeah, I mentioned this earlier, and this is like I said, big part of the impetus of this program in general was if you've been to an MCA meeting, you've heard me talk for sure, and you probably have heard a gentleman who I work very closely with by name of Andy Williams, who's also our lead technical folks at MCA. And we have council meetings and tech meetings. Our council meetings are about 45 minutes. Our tech meetings are usually about an hour and a half. And we have a lot of research programs, doing a lot of different things, and we are flying when we give these presentations. And so I've been told many times, look, that's great. We appreciate what you're doing, but can you give us a cheat sheet on the acronyms that you're using? And so that's what I'm going to do. And I think even if you don't come to MCA meetings, you'll find these good to know. And I'm going to give you a little background on a lot of them, because that's like anything else. It's not the acronym that's important, or knowing what the words are. It's why is that significant to us? So we're going to start with codes and standards. Very dear to my heart and Andy's. So, and probably most people know the ICC, International Code Council, are authors of the International Building Code, which is commonly referred to as the IBC. Maybe a lot of people don't know, though, that in order for a standard or provision to be brought into the code, it actually must be developed through a consensus-based process. Because you have to remember, building codes like IBC, by themselves are documents that don't really have any power or enforceability until they are enacted by statute within a jurisdiction. And the folks who assign or make that ruling, we call them AHJs, or authorities having jurisdiction. And they are the ones that essentially, by enacting this code in their jurisdiction, they are making it law. Because it is law, it has to be developed by some type of a standards, a consensus-based process, just like our legislation is done in the United States of America through Congress. Congressional hearings are open. Many of the committee meetings aren't, but the committees are bound to produce minutes that anybody can log in and read the minutes and see what they're up to. Obviously, congressional hearings are on television. So this whole process for building codes, this consensus-based process, is the requirements for this process is set by ANSI, the American National Standards Institute. So they accredit the standards development groups like ICC or some of the others we'll be talking about. And their key thing is to focus to ensure that fairness and equity has been used in developing of the standard, because it could become law. And that's very important in democratic society. We should not be able to pass laws that require certain things be done, and you have to go to this certain commercial entity to get them, right? That's not really part of the spirit. So one of the main ANSI accredited standards developers that we work with at MCA is the American Iron and Steel Institute. They produce a document called AISIS 100, amongst many, many others, that dictate the design, a structural design of cold form steel members made out of coil stock gauge material, just like with time. In fact, this 3/16 dividing line actually originates in AISC spec, but that's the design, the dividing thickness between these two codes, generally speaking. So we've worked very closely with AISI and others and they have users categories. They also have to announce certain types of development and committees that they're having, so that the public is aware that this is going on. Back up one more slide here. So that's okay. So just like AISI does for steel, the Aluminum Association does similar for aluminum. We haven't talked so much about aluminum, but we make a lot of aluminum products. We make a lot of roofing material out of aluminum products. A lot of Metal Construction Association members do that. And the Aluminum Association essentially provides a similar service to their industry by developing ANSI-based accredited standards dictating aluminum design. So there's their logos on the right-hand side. Next slide, please. We're going to continue down this code and standards path a little bit. The National Fire Protection Association, or NFPA, another one we monitor and work with very closely through other groups as well. They're a developer of codes and standards revolving around fire protection, as you might guess. They do a lot more than just that. They also have a model national code, and they do all kinds of standards for fire protection, firefighter equipment, firefighter tools. None of that really affects the building industry, although it's interesting that the 75-foot limit you see a lot, and for certain types of fire limitations for roof height on certain types of fire protection comes from the length of a ladder, for instance, of a typical ladder. So those are interrelated, and why NFPA sets a lot of those standards that do very closely affect our product, particularly if it's insulated with some type of combustible material. ASTM, probably everybody's heard of this, American Society for Testing of Materials. massive organization develops a gigantic library of standards. I'm not going to even begin to tell you how many there are. They're easily in the thousands. They do standard specifications, guides, all kinds of things. And pretty much any material that we've talked about, be it for steel, as covered by an ASTM A series spec. So they have A series, B series, C series, and excuse me, A, or generally speaking, the material series. C, D, and E, excuse me, C, D, and E cover different types of test processes and standards. But if you were to go through IBC and count, ASTM is cited more than any other organization in the hundreds of times for various things that they do. So very influential, important group. And I encourage a lot of people to join ASTM. It's a really interesting thing to do. It's a fun process to participate, can be challenging, but it's your chance to guide the industry from your own perspective. ASHRAE is very similar. Maybe doesn't affect metal construction exactly, but remember, we have members who make insulated metal panels and different types of insulated products. Even some of our members who don't do IMPs, insulated metal panels, might sell insulation, so they do concern themselves with this. So the American Society of Heating, Refrigeration, Air Conditioning Engineers, again, I'm only going to talk about what they do that affects us. They do a lot more than just make 90.1. But 90.1 is the standard governing minimum energy efficiency for commercial and multifamily residential buildings. It sets U factors for wall assemblies and equivalent R values. It sets air infiltration standards. It references this next group, Cool Roof Rating Councils, or CRRC, for cool roofing provisions. So CRRC, they're developers of CRRC 100, the standard governing cool roofing and related measurements and rated of aging properties. And that standard, I'm actually on the CRRC technical committee. We work with that standard virtually every time we meet. And it is beginning to be adopted and looked at very closely all throughout the United States now as people begin to concern themselves with heat island effect and how it relates to climate change. Right, so let's move a little bit from so we're getting into groups now that do certifications and listings, but they probably also do standards. UL is a good example of this. So throw them in the bucket with the standards developers that I just covered. But let's talk about certifications and listings in general first, as they're really two different things. A certification is a statement from a third party. Well, in this context, a third party who says that you have passed this test, or you meet this standard, or your spec or your product meets this specification, and it certifies that. Okay. A listing is a certification plus some other stuff. Specifically, what a listing means is your certifications are listed on a publicly accessible third-party hosted source, and those certifications also relate to a QC program, an annual inspection QC program, which verifies that the product that are certified, a product that is being certified, is being made at these particular plants in conductance with that same standard. And there's a third-party auditor who chases that down and makes sure that's all done. Why is that important? Well, not just public safety. Obviously, that's the most important thing. It has a lot to do with insurability. So if you want a building to be insurable, which you want, obviously, you need, generally speaking, to address a lot of UL standards. In fact, many of them are part of building code requirements. And, you know, it's insurability is kind of a little bit beyond what the code requires. I think you're all probably familiar with the old saying that the code defines the least performing building you can legally have. And even UL standards are cited a lot in the building code, but many of these UL standards go above and beyond what the minimum requirements of the codes are, and they do that for insurability. So major insurance underwriters will look for UL listed products in buildings, and they will make sure that they're have been designed, incorporated into design, so that they can provide greater levels of insurability. And then the next group I'm going to talk about here is factory mutual. So factory mutual is a similar organization from the standpoint that they're largely driven by insurability, but they really focus in on buildings containing or the insurability of buildings containing expensive equipment or goods. They call them HPLs. There's another one for you, highly protective loss. And if it's important enough to have an alarm, fire alarm, a burglar alarm, if it's important enough inside that building to protect it, then you need, the building itself needs to be as matched in security and durability, right? That's the whole idea. So they do this. They have two arms. They have FM approvals, which is the portion of FM that actually produces approval standards and then tests them. One of the interesting things about FM, they run all their tests through their facility in I think it's actually in Rhode Island, but it's right near the Connecticut border, and then they or Massachusetts border, excuse me, and they do all those tests, 100% of them at that one facility. The other arm is called FM Global. They are the ones that produce what they call the data sheets, which are the standards that kind of go beyond what the minimum building code requirements are in terms of what the structure has to be demand. So think of it as FM Global. And again, FM Global does more than just that, but that's what we care about. So FM Global sets the bar. FM Approvals assures that a product goes over that bar, so to speak. Similar group called ICC-ES or ICC Evaluations. They are certification and listing arm of ICC. They specialize in building products, windows, doors. You'll see some metal products, insulated metal panels. Many of them have ICC-ES listing. And that is for products that are not necessarily engineered specifically to project requirements, but those products have engineering in their design. And so the ICC-ES standards verifies to what level this product has been, to what standards it's been engineered to, probably is a better way to say that, and then produces that in a third-party publicly available third-party written source. So now an engineer can compare what ICC-ES is certified that to what the code requirements are and ensure they match up. So they're very important. And IAPMO, and the reason why I brought them up, they're an International Association of Plumbing and Mechanical Officials. Okay, big deal, Bob. What does that matter? Well, they are mostly focused on MAP systems, but they are moving into building products now. So you'll begin to see some building products that are listed under the IAPMO label now. And it's beginning to be more popular from what I see. It's still not anywhere near as popular as ICC-ES. But it is beginning to catch on a little bit more. You'll see it more often, but same function as far as building products are concerned. Next slide, please. I'm going to wrap this up, and I think we're pretty much done. This may be the last slide. And just a shout out to other trade association the MCA partners with. MBMA, the Metal Building Manufacturers Association. We do a lot of research together with them, and they are really in an area very uniquely dedicated to pre-engineer. I hate to say that they don't really use that term anymore, not pre-engineered buildings, but that's what probably a lot of people will know them. They're actually been termed Metal Building Systems or MBS. And they publish a lot of really cool standards. They're not an ANSI accredited standards developer, but they have really good standards and guides out there to help people specify metal buildings, a great source to look to. Others are, so advances, yeah, an NFBA, National Frame Builders Association. You probably, if you've done ag buildings, you know, you've heard of NFBA. Pole barns, you'll hear that saying. I won't go into what that is. It's an interesting way to build a building, and they really work very well for agricultural structures. We just don't have the time to get into that, but they do publish those standards. And they have now been adopted in the building code. I'm not sure, I don't think NFBA is an ANSI accredited standard, but I believe they've used another ANSI accredited agencies to canvass their standard. That's much like MCA has done with our edge metal tests. We used SBRI, the single ply roofing industry. We use their canvassing process. So we're not ANSI accredited standards developer, but we have an ANSI accredited standards, ANSI MCA FTS1, because we used somebody else's process. And of course, we partner with them and pay them money to host it for us. Steel Framing Industry Alliance. This is really focused around studs and specification of studs and stud materials, and promoting the use of stud construction in the building space. And probably my favorite acronym ever, ISANTA. the International Staple Nail and Tool Association. Now, I know that isn't the A and N are switched there, but I tell our executive director all the time, I joke with him, we need to change your name to, MCA needs to change your name to I Easter Bunny or I Tooth Fairy. No, we love ISAN. We work with them very closely. Todd says nails aren't as common in metal roofing. They are used for certain types of products, however. So we do work with them on those types of things. And another great association I love working with, the National Coil Coating Association. This is a group of coil coaters. So you can imagine we have coil that comes from a steel mill. We have paint that comes from a paint company, but now we got to put one on the other. And that is done through a coating manufacturing facility. These are very highly optimized systems that run in hundreds of lineal feet a minute, painting, priming, triple and finish coating this material at phenomenal rates of speed, close to 600 feet a lineal minute. For some of the thinner materials, the thicker ones, actually because of the heating that has to happen, their baked on finishes actually run a little slower, but in the hundreds of feet a minute. They're amazing, amazing groups. They have a very good trade association we love working with, and the National Coil Coating Association. And we work with many more, and some of these folks that we work with are on this call today, and I've missed them. I apologize, but we know who you are, and we appreciate all the work that you do and helping us. And we sure hope that at MCA that we're helping you to that same level. So that is it. And I'm all done. I guess if we got any questions in the chat, we can address those, and I'll turn it back to you.
Yeah, so we currently do not have any questions in the chat. The questions that did come through were regarding a few other minor things, a few other techie things, but everything was fantastic.
So somebody did comment. I love this. This is Christine. Thanks. You guys were riveting. There you go.
Yes, you were.
I don't know you, Christine, but I know I like you. All right.
Well, thank you both so very much. A huge thank you everyone out there to Todd Miller and to Bob Zabzik for doing this presentation for us. As a reminder to everybody here, if you are interested in anything to do with the Future Leaders program, please reach out to Zinat Ali or myself. You can reach me directly at kaylin@metalcon.com. If you're a member of the MCA, feel free to reach out to Zinat, and either of us will be more than happy to answer any questions you have about the programming. Again, a huge thank you to these two wonderful guys that stepped in and took on this huge project and created this whole presentation. And a big thank you to everyone here viewing live today and to anyone who will view in the future. Thanks all so much. We look forward to seeing you at the next one.
See you in MetalCon, folks. Come on, come all, bring your friends and family.
We'll
a fun time will be had by all, I promise.
This is very true. This is very true. We'll see you on that show floor, everybody.
Bye-bye.
Bye.
Bye.